Hi, I'm Steve, and I have two partners here, Joe and Jordan. We're part of the community college PLC class for Don Ruba, and this was our first test. What we had to do is simplify a Boolean equation, input it into a logic control circuit. So we started out with this long equation here, and fortunately we were able to simplify it to B and D. So what B and D is in our circuit is simplified B and D. We had to input it into a controller. So we had load B, 1, and because it's an AND circuit, and 2, and we called D as 2, and then the output we loaded as 200. So then once we got this completed and input, we were able to turn it on and upload it to the PLC. So we'll go over there and show how this circuit works.
So here's our whole setup that we have for the circuit that we had drawn up and proved out for logic. On our PLC controller here we have load 1 instruction on line 0. We have our AND instruction for input number 2. And then we also have, when those two are ANDed together, we have our output of 200 going out of the common over here on the PLC. We have the end statement there, which we have it set to run mode, so that's currently running on this PLC controller. And so if we end up doing our push button, which is number 2, you can see our input here lights up, which is proper. And then if we do our sensor over there, so as long as the screwdriver is down in front of the sensor, it works just fine. We can see our light is turned on and the sensor is getting extra supplementary voltage from this DC power supply, where both of the commons are wired up to here on our common rail for the PLC. Our input from the sensor goes to input 1, where once that senses and the light turns on there, you can see our input on the PLC is turned on. Now if I do both at the same time, which is our AND logic, you can see we have output 200, and you should have heard that our relay here is latching from our output that is on the AC side of our PLC for latching on either of them. So if I have the button pushed and we take away the screwdriver, it goes off. Either one, they have to have both of them, and then our output will be turned on properly.
So right here we have our logic control circuit schematic diagram. Right here we have our 3-wire sensor with the brown, black, and blue. That would be this sensor right here. We have our PLC block right here. We have our syncing side on the positive and our sourcing on the bottom. For the sensor, we have the brown coming in as positive. It's got a normally open switch, so that way when it gets energized, it turns on an input in the PLC. The black wire is our common going to input 1 in the PLC. Our blue is the negative going to 24 volts DC. So this whole left side is our input, and then from there going to the PLC. The brown jumps over to the common, or our syncing side of the PLC. We have our ground here, L2 and L1. L1's jumped over to our negative common, and L2 jumps through the coil and then also goes to the output for 200. So when we get our output, when the sensor is energized and our push button is closed, our output energizes, closing that contact, and that's how we get our output. Right here is just a little bit of a in-depth look at the 3-wire sensor that we have right here for an input. Got our limit switch on the inside, just a normally open contact. We have our load coming from the PLC, sourcing sensor, syncing PLC input.
So that would be the end of our whole project. Hopefully if there's anything that wasn't explained, you could ask us about it in the comments below. Other than that, thank you guys very much for watching. This has been Jordan, Joe, and Steve.